Okay, now a little bit of review from last chapter. We now have a third method or a third form that we can now write our parabolas in, and that is a factored form. So let's go back while we're talking about it and remind you of vertex form. So we have our standard form, which had the A's, B's, and C's in it. To change from standard form to vertex form, here was your steps. So you have your function. Let's go ahead and recopy it. Y equals x squared minus 8x plus 15. To get that in vertex form or transformation form, step number one, I move my 15 over. I'm left with x squared minus 8x. What I do is I now complete my square. So I'm going to put me a blank here. The way you complete the square is take half of this and multiply it times itself. Gives you 16. If you add a 16 to one side, you have to add it to both sides. You have negative 5 plus 16 is a positive 1. On the other side, as soon as you complete the square, you always factor next. This should be a perfect square trinomial. It's going to factor into x minus 4 times itself. You now move the 1 back over, and your vertex form is x minus 4 squared minus 1. Factored form, we're going to take that exact same y equals x squared minus 8x plus 15. And our factored form is two sets of parentheses. X times itself, adds, multiplies will be a negative 3 and a negative 5. Now to do the graph of this, what we could actually do is let's go back, and we can always use our factored form to very easily find our x-intercepts. We're going to set each of these equal to 0, solve it, and when you do, it gives you a 3, 0, and a 5, 0. Those are going to be your two x-intercepts. You can very easily use this form to find your vertex. This parabola has been moved right 4 and down 1, so therefore my vertex is going to be 4, 1. And you can use any of the forms to find other points, but that's going to be enough right there. So my vertex is 4, 1. 1, 2, 3, 4, 1. My zeros are located at 3, 0, and 5, 0. And that should have been 4, negative 1. So let's try that again. So let me move my vertex down 1. So 4, negative 1. So my parabola would look something like this. If you have the vertex and the zeros, then that gives you a pretty good graph. Okay, let's do another one. Number 2 gives you the exact same thing. You have your standard form. Let me recopy it up top. Okay, to get that in vertex form, step number 1, move the 6 over. You're left with negative 2 x squared minus 4x. If there's a number in front of x squared, now these are a little bit tougher, you do have to factor that out. So factor out the negative 2, you're left with an x squared plus 2x. And I'm going to leave a space in there. We're now going to complete the square. Take half of this, multiply it by itself, gives you a positive 1. If there's a number out front, you've got to multiply those back together to figure out what to add to the other side. So negative 1 times 2 means you're going to add a negative 2 to the other side. You now have y minus 8 equals negative 2 times. The factored form of that would be x plus 1 times itself. Move the minus 8 back over, and your vertex form is going to be y equals negative 2 parentheses x plus 1 squared plus 8. So your vertex, let's go ahead and list it. Your vertex is left 1, up 8. So your vertex is at negative 1, 8. Now let's take that exact same one and factor it. Okay, step number 1, to factor this, we're going to factor out our GCF, which is negative 2. You're left with x squared plus 2x minus 3. And that would be y is equal to negative 2 times x times itself gives you x squared, adds, multiplies would be a positive 3 and a negative 1. So therefore, set each of those factors equal to 0. And again, that gives you your x-intercepts. And those two x-intercepts, or we can call them roots, we can call them zeros, are going to be, if you set this equal to 0, gives you negative 3. Set this equal to 0, gives you a positive 1. We have a vertex at negative 1, 8. Let's go ahead and plot it. 1, 1, 2, 3, 4, 5, 6, 7, 8. You have roots at negative 3 and at a positive 1. So therefore, you have a picture kind of what your parabola looks like. Next one. Now this one we're working backwards. They give you a vertex form and we're asked to go, or a transformation form, and we're asked to go back to the other form. So let's copy it. And we've not done a lot of this, but it's not too bad. First step to get it back to our standard form, we're going to square the x minus 7. So that's x minus 7 times x minus 7. That does have to be FOILed out. Here's what you'll get. Or to square something, again, you can square this, multiply the two together and double it, and then square this, and it gives you the exact same answer. You now distribute that negative. You have to square it first and then put the negative on it, just like negative x squared. That's going to be negative x squared plus 14x minus 49, and we can go ahead and instead of writing that again, negative 49 plus 1 will be a negative 48. So there is my standard form. Since I already had my vertex form, I can very easily pull the vertex from that. Right 7, up 1. So there's my vertexes at 7, 1. Now let's go to a factored form. My original is now negative x squared plus 14x minus 48. Okay, now factored form of this would be y equals, factor the negative 1 out first, x squared minus 14x and a positive 48 is what you'll have inside parentheses. Bring down that negative 1. Two sets of parentheses, x times itself gives you x squared. As multiplies give you negative 14 and 48 will be a negative 6 and a negative 8. Set each factor equal to 0, and that gives you roots. Set this equal to 0 gives you 6. Set this equal to 0 gives you 8. So you have a vertex at 7, 1. So let's go ahead and plot it. 1, 2, 3, 4, 5, 6, 7, 1. And zeros at 6 and 8. So therefore here would be your parabola. Something like that. Okay, let's move on to the next one. And again, they give you the vertex form. So let's go ahead and copy that down and let's try to change it into standard form. Okay, step 1, to change it, I'm going to have to square the x minus 1. To square that, again, shortcuts, you can FOIL or you can just square this. Multiply the 2, gives you negative 1x, double it, and then multiply negative 1 times itself or square it. Now we're going to distribute that negative 3, gives me negative 3x squared, a positive 6x, and negative 3 times 1 would be a negative 3. And then you can go ahead and combine that like term if you want to, and that would be plus 0. And they cancel each other out. So therefore, there would be your standard form, negative 3x squared plus 6x. Now let's move on again to our vertex form. From this, let's go ahead and find our vertex. Negative 1 moves it right 1, positive 3 moves it up 3, remembering your transformations. Y equals negative 3x squared plus 6x. Let's now change that to a factored form. And this one's really easy to factor because the C term's missing. If C term's missing, then you have a GCF. Just factor out the negative 3x. You're left with an x and a negative 2. Set each factor equal to 0, and that tells you your roots. Set this equal to 0, negative 3x equals 0 gives you 0. Set this equal to 0 gives you 2. So you have a vertex at 1, 3. You have x-intercepts at 0 and 2. You see the symmetry there. So you have your parabola would look something like that. The next one, they give you a factored form of x plus 3 times x plus 7. So therefore, let me write that down. In order to get your standard form, you simply FOIL. That's it. That'd be y equals x times both would be x squared plus 7x. 3 times both would be plus 3x plus 21. Combine your middle terms, gives you y equals x squared plus 10x plus 21. Now let's take that standard form, write it in vertex form. To go to vertex form, we've got to complete the square. So step number 1, move the 21 over. You're left with x squared plus 10x. We can go ahead and complete our square from here. Take half of this and multiply it times itself. It gives you 25. Add it to both sides. Since there's no parentheses, you can just add exactly that 25. Negative 21 and 25 gives you 4. Let's factor the other side. It should be a perfect square when you factor it. X times itself. Take half of this to find your other part of your factored term. And you now have, move the 4 back over by subtracting, x plus 5 squared minus 4. So therefore your vertex would be, the plus 5 moves it left 5, the minus 4 moves it down 4, so that'd be a vertex of negative 5, negative 4. We can again use our factored form, the x plus 3 times x plus 7, to find our zeros or our roots, whatever you want to call it. Set each of these equal to 0. So you have zeros at negative 3 when you set this equal to 0, and negative 7 when you set that equal to 0. So let's go ahead and put our vertex at negative 5, negative 4. So that's going to be 1, 2, 3, 4, 5, 1, 2, 3, negative 4 right there. We have zeros at negative 1, 2, and 3, and negative 7. So therefore, my parabola looks something like that. Okay, next one. Okay, let's go over, and they give us again a factored form, negative x plus 4 squared. So that'd be y equals negative, and instead of x plus 4 squared, I'm going to write that as x plus 4 times x plus 4. So to get that in standard form, again, I'm going to multiply these first. Well, actually, let's use our shortcut. X plus 4 squared, that's going to be y equals, bring down the negative. X plus 4 squared, we're going to square the x. We're going to multiply the two together and double them. And then we're going to square the 4, which gives us 16. Distribute the negative gives you a negative x squared, a negative 8x, and a negative 16. There is your standard form. Now let's get that in vertex form. So let's recopy it. So step number 1, let's factor out the negative out, or remove the 16 over, and then factor out the negative. You're going to be left with negative x squared minus 8x. Factor that negative out. Leaves you with negative, and then x squared plus 8x. Leave yourself a space so you can complete the square. When you complete the square, take half of this, multiply it by itself, gives you 16. If there's anything outside of the parentheses, it must be distributed back to see what you add to the other side. Negative 1 times 16 is a negative 16. Those actually cancel. So you now have y equals, bring down the negative, adds, multiplies. This is a perfect square, should be. That'd be x plus 4 times itself, which actually gives you the exact same thing you had over here. And I did that for a reason. I just wanted to show you that sometimes vertex form and factor form is identical. So therefore, the vertex here has been moved left 4 and up 0. The factored form, and this is always the case when it's a perfect square, this ends up happening. You're going to set the factors equal to 0. So you're going to set x plus 4 equal to 0, and you're going to get negative 4. And that is also your 0. So you have the same value for the vertex and the 0, and here's why. 1, 2, 3, 4. There's only one solution. The vertex is the 0. Now what I'm going to do, just to make the graph look a little bit better, I'm going to do a couple more values, x, y, maybe plug in a negative 3 and negative 2. And you get a negative 1 and a negative 4. So now let's plot those. Negative 1, 2, 3, negative 1, negative 1, 2, negative 1, 2, 3, 4. And you can use your axis of symmetry to find a couple more points. That's the reason we only really needed 2. So therefore, there is your parabola. And again, you see the vertex again is your 0.